Hi dear students and viewers, welcome back. Dear students, in this video we are going to discuss about the what is velocity and what is average velocity and what is mean by instantaneous velocity. How the questions will be given in case of these topics in different competitive exams. That is the topic here in this video. Watch the video till end without any skip. Clear? Dear students, for the first time if you are watching my channel, please subscribe my channel and press the bell icon too. After watching the video, you must share your opinion as a comment. Then it will reach us to the more students and it is helpful to the so many students. At the same time children, already in Google Play Store, my app is there, Vinay Kumar Basics of Physics. To write the online exams, you must download the app from the Google Play Store. Without late, we are going to the topic. What is mean by velocity and what is mean by average velocity and what is mean by instantaneous velocity. Velocity is nothing but here the rate of displacement. Rate of displacement is called velocity. Is called velocity. The rate of displacement is called velocity, or it can be written like this also. The rate of position. You can write any one of these two. The rate of displacement or the rate of position is called velocity. So we can write a formula should be like this: velocity is equals to displacement by time. So velocity is equals to what? Displacement by time. That is the formula here. Dear students, it is a vector quantity. Velocity is the vector quantity. It is a vector. So what we know, dimensional formula of velocity. Dimensional formula. What it is simply for displacement what write L, for time T you can write LT inverse 1. So you can observe children, distance, velocity and speed both are having the same dimension formula and same units. Now you can write units here in SI meter per second and in CS centimeter per second. So this is simply about the velocity. So how we can represent the velocity? If you can keep like this, it is a vector velocity V. Clear? And now what is mean by average velocity? Average velocity, the total displacement covered by the body in particular time of interval. It is related to the particular time of interval. So that should be what we call here average velocity, the ratio of total displacement to the time interval. That should be what we call average velocity. On the time of average speed, what we can write? The total distance covered. The total distance covered by the body in particular time of interval, what it is called average speed. But in this case, average velocity means what? Total displacement covered by the body in particular time of interval. That's why here we can write V average is equals to total displacement. Total displacement by time taken or time interval. So this is the formula we are going to use. For example children, if the body is moving along a straight line path, body means here a particle, a car, anything whatever may be. So at the time of t1 its position is x1, at the time of t2 its position is x2. Clear? Then obviously here what is displacement? Displacement is nothing but here x2 minus x1, and time of interval is here t2 minus t1. T2 minus t1. Then what are here? V average is equals to x2 minus x1 by t2 minus t1. That is equals to what? Delta x by delta t. This is simply about the average velocity. The average velocity and velocity both are having the same dimension formula and same units. You have to remember that. The next thing is what is mean by instantaneous velocity. Instantaneous velocity, the velocity of the body at particular instant of time is called instantaneous velocity. the velocity of the body at particular instant of time. That should be what we call average velocity. The difference between the average velocity and instantaneous velocity is the average velocity can explain the complete result of the motion. That means that what here within the time of delta t it can reach the from position I am saying now here A to B. Within the time delta t the body can reach the point B. That means what here result of motion is completed. Average velocity can give the result of motion. That means what within the time of delta t the body can cover the displacement of delta x. It is clear thing. Average velocity can explain about the motion or result of motion of the body, but instantaneous velocity can explain the velocity at particular one instant. In between these two, t1 and t2, we can say particular time value. For example, I am going to say this is the 2 seconds and this is now 8 seconds. In between any these two particular 1 second, we are saying that the velocity is there. That velocity is what we call instantaneous velocity. So that is the difference between average velocity and instantaneous velocity. Average velocity can explain the result of motion, but instantaneous velocity can explain the velocity. Yes, students, how we can compare the instantaneous speed and instantaneous velocity? What is the instantaneous speed? Speed of the body at any instant of time is called instantaneous speed, and the velocity of the body at any instant of time is called instantaneous velocity. So all of you know distance is a scalar quantity, then speed also scalar quantity, then instantaneous speed also scalar quantity. Like that, displacement is vector, velocity is vector, and instantaneous velocity also a vector. That's why here instantaneous speed it is always positive, but instantaneous velocity is maybe positive or negative. To understand that, simply here comparison of instantaneous speed and instantaneous velocity. For example, we are talking about the like this. Here the body is projected like this and that should be reached the ground in this path. Here we are taking so many points on its path. At every point you have to draw the tangent lines. So that will give the, for example, I am saying now A, B, C, and this is the point D. We are selected 4 points A, B, C, D on the path of the object. At every point here we are drawing one tangent. The tangent line indicates the direction of instantaneous velocity. Direction of instantaneous velocity. Clear? That's why here the velocity is changes with respect to the time and position. Some possibilities are there here, even though the speed instantaneous speed is constant, but here the velocity changes. That's why instantaneous velocity also changes. Clear? And in this case, dear students, for example, I am saying now x is equal to some a minus a1t plus a2t2 square. It is a displacement equation. Then differentiation of this one, that should be gives the instantaneous velocity. Instantaneous velocity is equal to what? D by dt of x. That means what? D by dt of a minus a1t plus a2t square. That means what? Here it is the constant, there is no differentiation. Now it is minus a1 plus a2 into d by dt of t square. That means what? Minus a1 plus 2a2t. So that is the displacement here. Average velocity, instantaneous speed. That is what? V is equals to minus a1 plus 2a2t. For example, at starting time t is equals to 0, then what right here? V is equals to minus a1. Here V is equals to minus a1 is the instantaneous velocity. But if you can take mod of minus a1, that should be gives the instantaneous speed. Instantaneous speed, because it is only magnitude. Only magnitude. If you can consider it is negative symbol, that means what? Instantaneous velocity. Clear? The differentiation of the displacement gives the instantaneous velocity. Clear? Here equation is what? X is equals to a minus a1t plus a2 t2 square. So what we know, d by dx of formula is the d by dx of x to the power of n is equals to n into x to the power of n minus 1. Like that we can write this one is a is constant, that's why there is no differentiation here, minus a1t, a1 into d by dt of dt, that is what 1 will get, minus a1, and by using this formula we can write 2a2t, that is the instantaneous velocity. If we can take this one here, if t is equals to 0, we will write v is equals to minus a1. Minus a1 represents what? Here instantaneous velocity. If you can take them only magnitude, that should be here what it is? S, it is the magnitude value. In this case children, here instantaneous speed, it is always positive. Instantaneous velocity may be either it is positive or negative. Positive or negative. If you can take the curved linear motion, sometimes instantaneous speed is more than the instantaneous velocity. Clear? And next thing here we have another case, it is there to understand the instantaneous speed and instantaneous velocity. Some possibility is there having the magnitude is same for instantaneous velocity and instantaneous speed. There is some possibility for here instantaneous speed and instantaneous velocity. Velocity have same magnitude. Clear? So that's why here I am saying now this is the circular path. Just imagine at every point the particle is moving along a circular path. We have selected some points on the circular path. Here at every point we are saying its speed is 30 meter per second, 30 meter per second, 30, 30, 30, 30, 30. Yes, everywhere we have 30 meter per second, 30 meter per second. Here what is 30 meter per second? 30 meter per second is the magnitude. So magnitude is common for both average speed and here what we know already, I think you have idea. Speed is scalar and velocity is vector. Vector has both magnitude and direction. That's why here 30, here instantaneous speed has magnitude is what? 30, and velocity also having magnitude 30 meter per second. That's why here what you have to say, instantaneous speed and instantaneous velocity both are having the same magnitude. And now here if you can draw the tangent lines at different positions, that will give the direction of velocity. So in this case what you have to say, the direction of instantaneous velocity direction changes continuously. That's why here there is no possibility for having the same velocity, instantaneous velocity. Instantaneous velocity changes from one point to the another point because the direction of velocity changes. Velocity is the vector quantity, that's why it has both magnitude and direction. When direction changes, automatically velocity also changes. That's why even though magnitude is same, but velocity can changes. That's why instantaneous speed and average speed both are having the same magnitude, but the instantaneous velocity is not same along the circular path. Clear? Next thing you have to know when the velocity is uniform and when the velocity is non-uniform. Simply here what is meant by uniform velocity and what is meant by non-uniform velocity. If the body can covers equal displacements in equal intervals of time in the same direction, then the body is said to be in uniform velocity. If the body can covers equal displacements in equal intervals of time and in the same direction, then only the body is said to be in uniform velocity. For example here, so what we know, velocity is a vector that is having some magnitude and direction is there. Magnitude is there and direction is there. Clear? That's why here simply I am saying it is as t1, t2 like that. Now x1, x2 you can take so many things like x1, x2, x3 like that we can take t3, x3, t4, x4, t5, x5. Then t2 minus t1 is the time interval and x2 minus x1 is the displacement. Next x3, yes, like this. So we are having different intervals and different displacements. So here in this case we are saying delta x1, delta x whatever may be here. This is delta x dash and this is what delta x double dash like that. And this is delta t and delta t dash and delta t double dash like that. So here the displacements what we are taken that should be same. At the same time of intervals also same, and it is moving in a straight line path. Then magnitude is same and direction is same. Then obviously what you have to say, that should be in uniform velocity. And next thing is non-uniform velocity. What it is? If the body cannot or do not covers the equal displacements in equal intervals of time, then it is said to be in non-uniform velocity. So among these two, magnitude and direction, if anyone change, velocity can change. If you can take any motion other than the straight line, you can take curved motion or circular motion. In that case, direction changes, even though magnitude is same, but velocity is changes. Already we just only discussed. So that is simply about the non-uniform velocity. If the body can covers S unequal displacements or it is moving in different directions in equal intervals of time, then what you have to say, it is non-uniform velocity. Now let's discuss some problems, example problems which are very useful to the competitive exams. Let's go for that. See the first problem. In 1 second a particle goes from point A to point B moving in a semicircle. Find the magnitude of the average velocity. Find the magnitude of the average velocity. What you are saying is given one diagram. In 1 second particle is moving from A to E. Particle is moving from A to B. Then we have to find out the magnitude of average velocity. Magnitude of average velocity. Here it is a semicircle. That's why here it is the radius R and this is the radius R. So diameter R plus R 2R. Here this is the shortest path. A to B is the shortest path. The shortest path between 2 points, what we call displacement. What we call displacement. Here what we know? We know that average velocity is equals to what? Total displacement. Total displacement by time taken. Time taken. So he was given radius is what? 1 meter. That's why here what, right? Here 2r by t. V average is equals to what? 2r by t. Then what is 2 into 1.0 into, so 1.0 into 2 into 1.0 by, again t is what? 1 second. That means what, here we will get 2. So V average is equals to what? 2 meter per second. So this is the answer. Let's see one example regarding the average velocity. The given problem should be like this. A particle is moving along x-axis. Its x-coordinate varies with time as x is equals to 2t square plus 4t minus 6, where x is in meters and t is in seconds. Find the average velocity between the time interval t is equals to 0 to t is equals to 2 seconds. So what he was given? He was given displacement as the function like x is equals to 2t square plus 4t minus 6. Now we want to find out the average velocity. Average velocity. So he was, for example, at the time t is equals to 0, we will take x, displacement is x1. At time t is equals to 2 seconds, we will take that is x2. Then obviously what we write average velocity formula here, V average is equals to x2 minus x1 by t2 minus t1. t2 minus t1, that is the formula we are going to use. Clear? So here we will write at the time of what was given, t is equals to 0 and t is equals to 2 seconds. So x1 is equals to here, when the time is equals to 0 seconds, we have to substitute the t is equals to 0 in the given equation. x1 is equals to 2 into 0 square plus 4 into 0 minus 6. Then obviously x1 is equals to what? Minus 6 meters. And similarly, when the time value is t is equals to 2 seconds, then what are here? That is x2 we are saying now. Again we have to substitute the t value, t in 2 into t square plus 4 into 2. T value is 2 here, minus 6. Then x2 is equals to what? 2 into 4 plus 8 minus 6. 2 into 4, 8. 8 plus 8 minus 6. That is what? 16 minus 6, that is what? 10 meters. 10 meters. So here what you got? x1 is the minus 6 meters and x2 is the 10 meters. Then substitute here, V average is equals to here now 10 minus of minus 6 by t2. What is 2 seconds and t1 is 0. Then 10 minus of minus plus 10 plus 6 by 2, that is equals to what? 16 by 2. That means what? 8 meter per second. Therefore average velocity is equals to how much we got? 8 meter per second. Clear? Let's see another problem. A clock has its second hand 2.0 centimeters long. Find the average speed and modulus of average velocity of the tip of the second hand in 15 seconds. A clock has its second hand is 2.0 centimeters. What you are saying? One clock it is there. This is the clock. So in that seconds hand is there, seconds hand, that is having some length of, here it is 2.0 centimeters, 2.0 centimeters. Find the average speed and modulus of average velocity of the tip of the second in 15 seconds. So when the seconds hand 2.0 centimeters and if it can travel 15 seconds, then what is its average speed and average velocity? We have to find out it. So look here, very simple to understand. This is the circumference of the circular path followed by the seconds hand. So for example here, initially that should be here now. Seconds hand is initially at this point, and after 15 seconds, seconds hand will complete one rotation, means what? 1 minute is completed. 60 seconds. 15 means what? 1 by 4 of this one, that is what? 15 seconds. 60 by 4. When the second hand completes the one revolution or rotation, 1 minute time is completed. But what he was given, among that in 160 seconds only, it will go for only 15 seconds. That means what? It is A is the here starting point, and now it is the 15 seconds. 12, 3. Okay, 15 seconds. Now it is B. Here how much angle is there now? Here it is angle is 90 degrees. In this case we have to find out the average velocity and average speed. Now what I was drawn, this is AB is the here, it is the displacement. The shortest path between 2 points, what it is called? Displacement. Now the total distance travel is here A to B like this, and displacement travel is what? AB. Clear? So to understand that, I am drawing separately here now. So this is what? A to B. A to B is the total distance. And this AB is what? Total displacement travel. That's why here already we have idea about the formulas. What is the first thing? Average speed is equals to what? Total distance by time taken. time taken. Similarly, average velocity is equals to what? Total displacement. Displacement for time taken. Time taken we can write. Clear? So in this case, what is the total distance and what is the total displacement? So already was given about the time. What is time here? 15 seconds. In both cases, time is 15 seconds only. But what you have to find out? We want to find out the total distance and total displacement. So first I am going to write here total displacement. What is displacement? So for example, I am saying now it is x. X is the displacement here, and now it is the radius, and this also radius. According to Pythagoras, what, right? X square is equals to here r square plus r square. Hypotenuse square is equals to side square plus side square. Then what is x square is equals to r square plus r square. That is what? 2r square. Then x square is equals to 2r square. It means that x is equals to root 2r. X is equals to what? Root 2r. And what is the radius of the radius here? That is nothing but length of the second side. That is what? 2.0 centimeters. 2.0 centimeters. That's why simply here the displacement is what here? Root 2 into 2. 2.0. That means what? Displacement is 2 root 2. 2 root 2. So that is what? Total displacement. Now what we write here? Average velocity is equals to average velocity is equals to total displacement. How much was? X is equals to what? 2 root 2. So 2 root 2 by time is what? 15 seconds. So now this is what here? Obviously centimeter per second, this one. 2 root 2 centimeter per second. And now in this case, what is total distance? What is total distance? So for example, if the second hand started from this point A, and again if it reaches the same point A, then one rotation is completed. One rotation means what here? Nothing but circumference of the circle. Circumference of the circle. Once it is started from this point A, that should be travels along the circular path and reaches the again same point. That means what? Initial point and final point both are same. In that case, the distance traveled is what? 2 pi r. 2 pi r. So that's why here for one rotation distance is equals to what? 2 pi r. 2 pi r. But what it is here? This is the only 1/4 part. 1/4 of the circle. 1/4 of the circle. That's why here in this case total distance is equals to here 2 pi r by 4. 2 pi r by 4. Again here what is 2 into pi into r value also radius is 2 by 4. Then what is here? 2 into 2 4 cancel. Then what do you have? Pi is there. So this is what? Total distance. So understand children, for one rotation the total distance is 2 pi r, but in this case only 1/4 portion of only the particle is moving. That's why here in this case the blue portion what you are finding here, that is the total distance. That should be what? 2 pi r by 4, that is equals to what? Pi. Then obviously here now we will write average speed is equals to average speed. Average speed is equals to what? Total distance is what? Pi. And time is what? 15 seconds. Yes, this is what? Pi by 15. So centimeter per second. So in this way we will find out the average speed and average velocity. It's very clear. See the next problem. In this problem we have detailed explanation for different cases. Look here. The position of an object moving along x-axis is given by x is equals to 3t minus 4t square plus t cube, where x is in meters and t is in seconds. Find the position of the object at the following values of t. When time t is equals to 2 seconds, we have to find out the displacement. When time 4 seconds, we have to find out the displacement. And third one is, what is the object's displacement when t is equals to 0 to t is equals to 4 seconds. In between t is equals to 0 seconds and 4 seconds, we have to find out the object's displacement. And fourth one, what is its average velocity for the interval between the 2 seconds to the 4 seconds. We want to find out the average velocity between 2 seconds and 4 seconds. That is the problem here. So the first thing, what is first? We have to find out the displacement of the object when time is equals to 2 seconds. when time is equals to 2 seconds, what is the displacement? That is we have to find out. So already was given equation, what is x is equals to here, x is equals to 3t minus 4t square plus t cube is there. Just you have to substitute the value of time 2. X is equals to 3 of 2 in minus 4 into 2 square plus 2 whole cube. So x is equals to what? 6 minus 4 into 4 plus here 2 cube, 2 into 2 into 2, 8. Then x is equals to what? 6 minus 16 plus 8 minus 4 into 4, 16. 6 minus 16 plus 8. Therefore x is equals to what? 24 minus 16. Sorry, 6 plus 8, 14. 6 plus 8, 14 and minus 16. Then x is equals to what? Minus 2 meters. This is the displacement of the object when time is equals to 2 seconds. That is the first one. And similarly here now, what is second one? We want to find out the displacement when the time is 4 seconds. When the time is the 4 seconds. Again same thing here. In this case t is equals to what? 4 seconds. 4 seconds. Clear? Again we have to substitute the t is equals to 4 here. 3t minus 4t square plus t cube. Then x is equals to what? 3 into 4. 4 into 4 square plus 4 whole cube. Clear? Then x is equals to what here? 3 into 4, 12. 4 into 4 square minus 4 cube plus 4 cube. Now these two are cancelled. Then x is equals to what? 12. X is equals to 12 meters when t is equals to 4 seconds. And now third one. What is third one? What is the object displacement between t is equals to 0 and t is equals to 4? T is equals to 4. Already we have t is equals to 4. Then what is displacement here? 12 meters. Now we have to take t is equals to 0 and t is equals to 4. When t is equals to 0, I am going to take x0. Then what is the here value? 3 into t. 3 into 0 minus 4 into 0 square plus 0 whole cube. Then what do you get? Obviously here x0 is equals to 0. X0 is equals to 0. So already when we have time t is equals to what it is? 12 meters. Therefore x0 minus x is equals to what is here? Simply x minus x0. What is 12 minus 0? That is 12 meters. Clear? When x is equals to 0, displacement is 0. When x is equals to 4, so when t is equals to 0, x is 0. When t is equals to 4 seconds, what you have? X is equals to 12. Then we have to find out the third one. What is displacement in between t is equals to 0 and t is equals to 4? When t is equals to 0, x is 0. When t is 4, x is 12. The displacement is what? 12 minus 0. That is what? 12 meters. And finally fourth one. What it is? Average velocity we have to find out. Average velocity. So average velocity is equals to here total displacement by total time taken. Total time taken. So V average is equals to here. I am going to take, this is the what is in between t seconds, 2 seconds and 4 seconds. 2 seconds is the t1 and 4 seconds is the t2. Then what are here? t2 minus t1. And similarly here when t is equals to 4, the value is what? X. X minus, when we have 2 seconds, 2 seconds, this x is minus 2. So I am saying, for example, if it is taken as here, this is x2 and this is some x1, then what at x2 minus x1, that is equals to x2 is what? Here 12 minus of x1 is what? Minus 2 by 4 minus 2, that is what? 14 by 2. 14 by 2. Look, very simple. What is the fourth one? What is the average velocity for the time interval? T is equals to 2 seconds. When t is equals to t1, I am saying t1 is 2 seconds, then displacement is minus 2 meters. When t is equals to t2, I am taking 4 seconds, then the displacement is x2, that is what? 12 meters. Therefore x2 minus x1, x2 is 12 and x1 is minus 2. 12 minus of minus 2, 14, and 4 minus 2, 2, that is what? 7 meter per second. So that is the average velocity. So this is the children, we have different situations like this. So I hope you understand. If you can understand this one, please like, share, comment the video and subscribe my channel to get all the notifications. And my request is, if you want to write the online exams, then download the app N. Vinay Kumar Basics of Physics from the Google Play Store. Okay, thank you for watching.